might have your own flow or data chat protocol that you use at your school. This is very similar and pulls together lots of different research data chat protocols. So we're first going to just start by, if we have data from an assessment, like how can we understand it and then make some meaning from it? So we'll take a beat to observe the data, because there might be a lot of data, as you kind of saw in the reports. We'll then add some analysis to it of what does this mean about student mastery. We'll think about what are our next steps, what are the implications for our classroom, and then we'll reflect. But I wanted to give you some actual data from a district on our site and really go through how can we make meaning of all of these different data points. So just to kind of walk through what this data is, and then I'm going to give you a quiet moment to read through the data. This is some three-dimensional data, so we can, of course, see our disciplinary core ideas, science and engineering practices, and cross-cutting concepts. So our three sections are here. We then, this is going to be, because I know we're kind of middle school to high school range today. I just picked some data kind of in the middle. So I picked some middle school data. That's life science. You'll see that kind of in the little standards tags here. It says MSLS 1.6, MSLS 1.7. So this large category up here, 45%, is an average of the scores underneath. So when you kind of break apart the data on InnerOrbit and you keep clicking on it to get down to that element, just remember that all of that data is averaged up and it is weighted based upon number of questions, if that makes sense. Because one data point might have a lot more data to it and be more meaningful than just a data point that has one question attached to it. So this is the LS1 molecules and molecules to organisms, structures and processes, life science, DCI. Then the SEP down here is going to be developing using models. So there's two little elements underneath there. And then the cross-cutting concept is scale, proportion, and quantity. And here we have some data on three pieces of that dimension. But the first step we recommend when approaching, so this is the data from the dimensions report, which we just looked at. The first step we recommend is to make some observations and to answer this guiding question, what do you see? So it might seem basic, right? Because we're observing, but sometimes when there's lots of data like this, really being able to think through students excelled with these specific pieces or students struggled with these specific pieces, really pulling some pieces of the data that we can see specifically where they're excelling or struggling to the surface is helpful to kind of take us to our analysis next steps. So here we're only discussing observations. We're not adding interpretation or any judgment to it. Well, we are saying if they're excelling or struggling, but we're not adding any of our interpretations of what that actually means about student performance. We're just observing. Aha, y'all are doing great. I see a couple next steps in terms of analysis of what does this mean about student performance. I mean, that's natural, right? We're always going to jump to what does this data mean? But some observations, so that I see in the chat that are without interpretation is with the DCIs and that content. Someone said they are doing great with growth and development of organisms, but are struggling with matter and energy flow. Great observation. Also, someone mentioned that out of the three dimensions, modeling had the lowest overall percentage, so struggled with that the most. Let's see if there's any other observations. Yeah, that's great. Perfect. Okay, so let's boogie to this next slide. And some of you have already done some analysis, so I'll make sure to point that out because there's some nice pieces there. But now once we have those nuggets of observations, let's go ahead and look at those pieces we've lifted to the surface and think about what does that data suggest about what they're struggling with versus what they're excelling with. So we can be thinking through students struggled with X because of Y, or students excelled with A because of B. So here we're kind of adding that interpretation to why might this data be the way it is. And of course, this is not our data. We're void of context here. So we're going to be, making lots of assumptions here, but what we're doing is we're trying to make sense of what the data says and why that might be the case. And we're not problem solving just yet. If this was your own data, you might be like, oh, we need to change this lesson and, this, activity. We're not doing that just yet, but some analysis pieces that I do see in the chat And one person like really hit the nail on the head too, that they're struggling with more abstract concepts. So we'll kind of really pull that out. But when we're looking at abstract concepts, some of the observations that support that analysis is matter and energy flow is much more abstract than growth and development of organisms. Kids can see pictures of an embryo, changing over time, even though they might not be able to, physically manipulate those organisms. They can see the pictures over time, or structure and function. They can look at an image of a bat wing and look and see, how is this wing structured? But matter and energy is a little more of an abstract idea. And when you look at the, here, I'm going to go ahead and cut to the chase and pull up some of my arrows here so y'all can see which ones I'm pointing at. When you look at the element for developing and using models that develop a model to describe unobservable mechanisms down here, that is really focusing on that idea of not just modeling, to predict or describe phenomena, which they also struggled with, but how can you model or visually represent something unobservable? Matter and energy flow is a little bit more unobservable than some of those other, DCIs, so that connects. And then even in that cross-cutting concept, even though they're doing pretty great with that last bullet point down at the bottom, do y'all see that? The 68%, that phenomena can be observed at one scale, may not be observable at another scale. So that's just saying they know that some things can be observed and some things can't be observed, but can they actually model those unobservable things like time, space, and more than likely what was being assessed here, that energy being modeled at different scales. So all of those like 3 different observations can pull together this one idea that students are struggling with abstract ideas. So what's really interesting about this data is if we just had data on the DCIs, we might get to that point. But here, when we have that conclusion, that piece of analysis, but when we can really see that they're having a trouble modeling the unobservable mechanisms, that tells us that maybe some visualization is missing that we might need to provide or remedy. And that understanding the scale maybe and those visualizations is a way we can help with that modeling practice. So that's a great piece of analysis that we pulled some observations from this data, looked across where they're struggling to see what's a pattern we see in those different data points. Perfect. Okay, so let's do the last little piece here, which is about implications. So from that analysis, so let's just take that one main analysis we had, that students are struggling with unobservable mechanisms or abstract concepts. What could we do about it? So we can extend students' learning by doing something specific, or we can support students' growth by doing specific things. So here's where we're thinking about specific action items that we can take based upon that analysis we made on the last step. So that piece of analysis we said in the last step is that students are struggling with abstract ideas. What might you do in your classroom to support that if that were the case for your kids? So I'll give you a couple of seconds to think, and feel free to share that in the chat as well. But this is where you as a team, and this is what's so cool about this data, is that you all as a team can really discuss what does that mean for us. So we might not be circling back to life science for a while, but I know in the next unit, we're going to be talking about chemical reactions. And that's a lot of abstract ideas and unobservable pieces. So what could we do in that unit to really tighten up their understanding of those abstract ideas? So science, as you know, spirals, and it's not just applicable to life science, that these findings can apply to whatever you're teaching next too, which is great. And then to wrap up this data chat, we have some reflection questions that if you're wanting to kind of reflect as a team about how that data chat protocol went, these questions are really helpful to reflect on that analysis. So we have this data chat protocol, and in a second, I'm going to drop the link to it in the chat. So if you want to follow these steps with your team, or even just independently with your own data, you can. And it can be as quick as 30 minutes that you take some time to observe the data, do a little bit of analysis, think about next steps, and then reflect. So you're just making those small instructional tweaks as you go. You don't have to be drowning in data all the time, but just taking the moment to pull some analysis, talk with some colleagues of what can we do about that, and then move on is exactly what we aim to support y'all with.